Hey folks, today in this particular video, we will be going to start a particular series. Okay, we will be going to understand more about interview questions, interview prep with into the details. Okay, so previously, which possibility of a questions that might ask, we have curated and engaged in the comment section below. Okay, so what I am thinking of, so from the internet, like possibility of a questions I am getting curated and what are the source of reference where we can understand more about this particular concept. So you will able to understand that prospect a lot of in detail. So in this particular video we will be going to discuss about. So let's get dive into it. What is a central limit theorem and why it is important? We'll just try to understand more about it. So we'll just go through the uh, particular blog where I found it. This one is very important. Okay. I will be putting this particular resource into a comment down below so you can check it out that first. Okay, we'll just get dive into it. What is a central limit theorem and what possibility and how you can go through this particular understanding. We'll be going to understand how to approach that and how to explain them with the concept based. Okay, so introduction to central limit theorem in world of loop full of data that will follows a nice theoretical distribution, the central limit theorem, beacon of light. Okay, so if you wanted to get through the central limit theorem, particular Wikipedia kind of sort of stuff reference, you will get it here as well. So you can go through that content as well, folks. So what's the central limit theorem? What is it is talking about? It lot more details into it. Okay. So math around it, how it is about all the stuffs you can go through that content, but not it is in this particular field that is not an objective in this particular video. All right. So, what is the motivation for this particular uh, mm, this particular video is motivation about the central limit theorem. Suppose that we are interested in estimating average height among all people. Collecting the data for every person in the world is impractical, right? Obviously, right? So bordering on possible. So while we can't obtain a height measurement from everyone in the population, we can still sample some people. Okay, so the question now becomes what we say that the average height of an entire population given a single sample. Okay, so the central limit theorem addresses the question exactly. Okay, so formally it states that if we sample from population, you see sufficiently large sample size, the mean of the samples will be normally distributed. Okay, so what specifically important is that is true will be true regardless of distribution of original population. When I first read the description, I do not completely understand what it meant. Okay, however, after visualizing the few example, it becomes clear. Okay, so let's take an example of central limit theorem in action. Suppose we have a distribution, population distribution. We have an observation of 0, 20, 40, 60, 80, and 100, and frequency is like 0, 2, 4, 6, 8, 10, 12. Okay, so manually generated from the above population choosing from 0 to 100. Okay, all right, observation. It is plotted in the histogram. The height of an histogram denotes the frequency of number in the population. As we can see, the distribution is pretty ugly, right? Certain it is isn't it certainly is not a normal, uniform, or any common known distribution. So, in order to sample from above distribution, we define the sample size, referred to as n. Okay, sample size we will refer to as capital N. Okay, suppose that we choose n to be 3. Okay, this means that we sample in the groups of three. Three groups we are taking into consideration. So for above population, we might sample groups such as 5, 20, and 41. Okay, 5, 20, and 41, and 41, and 60, 17, and 82, 18, 13, and 61, and so on. Okay. Suppose that we gather the thousands of a samples of a 3 from above population. For each sample, we can compute the average. If we do that, we will have 1,000 averages. So this set of 1,000 averages is called as sample distribution, sampling distribution. And according to the central limit theorem, the sampling distribution will approach a normal distribution. As a sample size n used to produce it increases, here is what our sample distribution look like for n equal to 3. So if you observe this distribution, it is fair enough, it is looking like a normal distribution, right folks? Okay. So as we can see that it is certainly looking like a uni model. Okay. So it is not necessarily normal. So if we repeat the same process, larger the sample size, we should see the sampling distribution starting to become more normal. Let's say we will increase the sample size. We have first what we did n equal to 3. So we once again we increases the sample size n equal to 10. So here is the sampling distribution for that sample size. All right. So this certainly looks like normal. If we repeat the process n equal to 30, we observe this result. Okay. So we will also get the this like this. So what's further intuition will be going like? So when I first saw the example of central theorem look like this, right? So I didn't really understood why it worked. The best intuition that I have came across involves the example of flipping a coin. Suppose that we have a fair coin, we flip it in the 100 times. If we observe 48 heads and 52 tails, we would probably not be very surprised. Similarly, if we observe 40 heads and 60 tails, so we would be probably still not be very surprised, but rare than 48 by 52 scenario. So if we observe 20 heads and 80 tails, we might to start the question the fairness of the coin. This is essentially what the normalness of the sample distribution represents for the coin example. We are likely to get above half heads and half tails. Okay, expected 50-50 result as less likely. So the normal distribution of sampling distribution capture this concept. Okay, normal distribution of sampling distribution capture this concept basically, right? The meaning of the sampling distribution will approximate the mean of true population distribution. Additionally, the variance of sampling distribution is function to both population variance and sample size used. Larger the sample size will produce the smaller the sampling distribution variance. Okay, so it makes an intuitive sense for considering more sample when using the larger sample size and more likely to get the representative sample of the population. So roughly speaking, if sample size is large enough, there is a good chance that it will estimate the population pretty well. Most sources that to estimate the applications n equal to 30 is sufficient. So these principles help us to reason that the samples for any population, depending on the scenario and the information available, the way that is applied may vary. For example, in some situation, we might know that true population mean and variance, which would allows us to compute the variance of any sampling distribution. Okay. However, in other situations such as original problem we discussed, estimating the average human height, we won't know the true population mean and variance. Understanding the nuances of the sampling distribution and central limit theorem is the essential first step talking about many of these problems. Okay, so these are the things like you will be like why central limit theorem, like main core idea about it. You will get to understand like central limit theorem, why it is important, what it will be going to talk about it. You will be going to understand about this reference basically. So we'll get dive into it here. Suppose that we are interested in estimating high average height of the all people. Collecting the data for every person in the world is impacted, bordering impossible while we can't obtain a height measurement for every in the population. So we can still sample some people. Question how becomes now becomes like what we can say that average height of the entire population became on a single sample. So central limit theorem addressed this question exactly. Formally, it says that if we sample from a population using a sufficiently larger sample size, mean of a sample also known as sample population. Okay. So and will be normal distributed, the mean tending to the mean of the population and variation equal to the variance of the population divided by the size of the sampling basically. So This is what we understood, right? So this is only in that blog article, whatever we have written, whatever we understood from that blog article, I have curated this particular thing, folks. Okay, so you can. I hope this thing you got an idea what is a central limit theorem and why it is important. Okay, so if you want this kind of a reference, kind of a materials, folks, just keep watching this particular video and keep like and subscribing to that to this channel so that I will be going to curate this particular kind of content. You will be able to receive this particular content. Okay, so I hope you like this particular video. I want 1,000 to 2,000 likes in this particular video, and do subscribe to my channel so that I can create such kind of a videos. So like as of now you have seen like there are plenty of videos they are talking about it only conceptual part. All right, so they are not talking about what are the possibility questions and how you can tackle them, how you can solve them, right? So this is the kind of the things you have to keep keep understanding what is that, like what at the end of the day is like you have to give the interviews and you have to crack that interview and you have to speak it very boldly and what is this particular means, right? So this is all about. I hope this video you like this particular video. We will meet in the next video with new another question basically. Okay, that's it about this video, folks. I hope you liked it. We'll meet in another video with the reference article and uh, like I will be going to tagging the link as well, so you can go through that as well. Okay. So next particular question we'll be going to discuss in the next video. Okay. So we will be going to understand that. Okay. This is a very long video, folks. Now, in the next video, we'll